Hello, everybody, and welcome to the intro for episode 20. Now, I've done something similar for, I think it was a couple episodes ago, because it was possibly even three. It was a very slow episode, but I still thought it was useful. I actually did not mind the outcome, so I kept it because I thought it was an important part of the process, but not everybody, might have been interested in watching it, or fair warning that not much would have happened, and therefore you can sort of keep it in the background now. And it has happened before, twice I believe, and we're close to 40 episodes now, so that's not very often. I was just unhappy with how a stream actually went and simply decided to redo it. So I simply discarded those recordings, and the following stream I will just repeat that day. Now, this is a slightly different case. So episode 20, I am gonna keep it. You're gonna find it after this video, in fact, and I'm gonna keep it for a couple of reasons. The first one is that in that episode we set off to finish the guide for the leg, which is mostly adding the knee and polishing up a couple of things, and it did get there eventually. It was also fairly clean for the full first half of it. There's some interesting information when it comes to assets and visualizing them. So it's got its place. It should be out. I don't want to restream it. I think it's valuable. But I thought that it would be worth to give it an intro for a different reason. So up to about half the episode, and somewhere between the half and last third of it, things go from very clean and obvious to I had to figure out a couple of things, phase, then something wasn't quite working the way I wanted it. So this intro is to clarify before you get into the episode 20 proper some of that stuff. And the reason for this is that I don't want the last third of it, because there's a couple mistakes, my mistakes in there. I don't want that last third to be confusing. So I believe that if I explain a couple of things now, that last third won't be confusing. You'll kind of know the punchline of how things were fixed at the very end. The other thing is that bang on by the end of the episode, I was like, okay, I'm not quite sure I understand why this fixed something. Then I stopped recording. The stream went on for another 5 minutes sometimes. There's a little bit of a post stream, and then exactly as I finished recording, was oh yeah, I get it. So let's do something useful here in this pre-stream, and as an intro to something that you will see in the actual episode, explain how constraints work. Because I've been talking about constraints being cyclic before and how to break it. The aim constraint is a little bit special, because it needs to do something that is even more inner loop kind of cyclic than a parent constraint will be. So the idea of an aim constraint is that you want an object to face another object. Usual thing in Maya, you select two objects in the master-slave order. Aim constraint, a DAG node is created under the constrained object so that you can get offsets for it, so that it follows the object that it's working with, and all of that. Now the results are interesting though, because this is probably doing what you want. Now the axis is off, and we'll show what that means. But there's a few caveats with it. So normally, and I've explained this before, constraints come in cyclic. Now the main cycle is that for a constraint to work, and you might need to be on top of some of our past math lessons to fully understand this, but it shouldn't be too hard. A constraint is cyclic because this constraint basically, any constraint basically means to infer a new local transform. So this is going to be relative to a parent that might be here, another parent that might be here, and it needs to know for these word positions. So let's say that this cube is red. This word position here, I will very much like to do something on my slave object that relates to that. So to do that, what the constraint actually needs to contemplate is, let's say that blue is the hierarchy of these. It needs to know the transform of its parent, because that way what happens, and this includes preserving the offset, which will be the transform that moves from the parent to here and all of that stuff. It can take the word position of the cube, look at that word position relative to the parent of the object that you're constraining, contemplate the offset, and that's what drives everything. Now, the reason it's cyclic is that it wants to do some work for you, and there's use cases, there's legitimate use cases for why it works that way. It's not the most economical, but it's the most general, which is if you were to reparent this cone, which is now, so this is called constraint and it's parented under something. If you were to parenting, and parent of parent is in the word, if you were to parent it under something else, how does it know what that something else is? You would have to rehook the constraint every time. So what it does is, and I think I've explained this before, but I think it's worth dedicating this mini episode / intro to it. What it does is every object in my, every transform in my, at least every diagonal that has a transform, has a knowledge of its parent that's communicated through parent inverse matrix, and I think you have parent matrix as well. So these attribute changes when you reparent this object under something else. By instating this cycle, where this constraint is actually driving the rotation of the constraint node, but it is actually being driven by an attribute that is on the node itself, it basically becomes hierarchy aware. Now, there might be a plus or a minus depending on how you look at things. If you're fairly confident in your hierarchy, you don't need to re-hierarchize, you don't need to reparent things dynamically, you don't need this at all. If you're willing to rehook it up when you reparent something. So to eliminate that cycle, that's pretty trivial. All you need to do is you sever this connection. So at this point, it's a static value, and that's why you don't see it popping or doing anything silly. You take the actual parent of the constraint object that before was being referenced by this, let's call it a virtual attribute, though it's absolutely not, but for the sake of explanation. It wants an inverse matrix, and for that I really have to send you to our math videos if you don't know what it is, but it's not particularly important to the cycling, acyclic kind of nature of the problem. You can hook that up directly, and at that point you're good. Now, if you were to reparent this constraint object, then you would also need to take its parent, so arrow up or whatever you want to do, and hook that up in there instead of the previous parent. Now, that gets rid of one cycle. And so let's offset this stuff a little bit so that we know what we're doing. Now there's other cyclic elements to it, and if you start from a parent constraint, that's going to be more obvious. So if you're practicing on these, go for that. Now the other thing it needs to do is when it outputs a rotation that is not the point constraint, which is just position, but when it outputs a rotation as part of the transform, or even just a rotation maybe, because it's output into a local, there is free attributes for an Euler rotation, which means the rotate order matters. Now the rotate order itself is contained on the constrainee, on the slave object. So the only way for this to know dynamically how to basically output the rotation to that object, well, that's another cycle. And again, you know, cycles are not necessarily bad. They can cause you performance, they can create clustering in the graph that needs to be disentangled and all of that, but it's not always a killer. So if you only have one or two here and there and they're useful, like I'm gonna be using one this season, like you'll see it in the following episode, it's okay. They are fine. But if you can get rid of those cycles, that's for the better. So if this is something where the animator might want, if it's an actual control, I wouldn't advocate constraining, you know, a local transform on control. Normally you'll do it on a buffer. If it's an actual something where the animator might change the rotate order, you can't work around this. If the rotate order changes, unless you install callbacks or something like that and you don't allow for animation, it's got to come from this. But in our case, we are in control of the rotate order here because this is going to be a buffer for whatever reason. So you get rid of that as well. And that's another part of the cycle gone. Now, the last part, and And this is one of several reasons why I don't use the pivots in Maya, why I like to do things with buffers in the actual DAG, even if they have a little bit of a cost. A, simplifies the amount of things I have to consider, relying on the fact that the pivot is always going to be zeroed out. But the other thing is that if you have an animated pivot, that's another thing where Maya does need a cycle. It's a benign cycle, but it needs it. It's not that they're doing something stupid or designed this badly, but for the general case where you want everybody to use these both as a rigging kind of tool as well as a general animation tool, a shot handling tool or something like that, they gotta do it. So if we leave the pivot alone, we can also get rid of that. And that's cool. Now, if this was a parent constraint or a point constraint, you'd be pretty much done. But the aim constraint has one interesting quality to it, which is if this object needs to face this other object. When you move the object around, if you think about what the facing represents for you, it only makes sense that the object's rotation is affected by its translation. And now it is basically impossible, if you want this behavior, to do it without this cycle. And this is, in a way, at least to me, it's even a slightly nastier cycle than some of the others. Now, if you're wondering whether it's legal or not, you have to remember that translate, rotate, and scale, these attributes take into consideration the transform that you have with the parent. So there's a parent, and then separately, the translate, the rotate, and the scale are added to that parent's transformation. It's a matrix multiplication, if you will. So what they do affects the word matrix of this object, which then goes down to its eventual children. So in this case, and the manipulators are very artificial things, so do not take them as indication of anything. So what is happening here is that translate, rotate, and scale are completely independent of each other, which makes perfect sense. So you can have the translate doing something that affects the rotate. And if you don't look at these nodes as the cycle, but if you look at a slightly finer grained version of these, the kind of dependencies we're looking at here, the cycles we're looking at, is consider like this as the parent of the object. It's going out to this node, and that for in two ways it needs to determine the parent space of the node itself. It needs to establish what this constraint will do. Now, that requires the translate from this node, which is dependent on that. So let's say that consider this translate as if it was another node. Let me actually do it a little bit cleaner. Now that still hasn't received anything from these, so it can legitimately go back to this node, to the constraint node, and inform it further by basically saying, hey, look at this parent position, then add the translation from this node, from the constraint object. Now you can do your computation, which gets me a rotation, and that is the rotation for this constraint transform, and that can then go out to the shape that is drawn in the viewport. So if for a moment you decouple the attributes and you imagine them as if they were your nodes in your dependency, you can see that this is a benign cycle. Now the fact that Maya groups those attributes under a node means that it's sort of as, for the sake of explanation, it's sort of as if this was a compound node, and when a cycle like this is found, you can imagine these being duplicated. It's a sort of a graph expansion, and this is probably not super dissimilar to what the parallel evaluation does by evaluating the DG and building a parallel graph and then evaluating that graph. You could think of this as an expansion where this constraint node, so this thing that we just sketched here, is basically done twice, where you have the parent of something, it goes into this, it goes into this constraint node, it affects this node once. So let's say that that's our node. Let's say that this is A and this is B and this is C. So we'll go, okay, if I were to duplicate this node and ignore the rotate connection, and this is why I started from a little bit of set and graph theory. Let's say that this is C prime. It's the first version of these. I can do all of this work. Then that gets the translation out. I could go, I'm going to lose this overlay, but at this point, I believe that you understand what these letters and what nodes these are. At this point, I can go out to a version of B that requires that translate. So let's say that that's B prime. Now that can now go, sorry, this should be by the Acylic convention we've just been using. That will be B prime, and this will be, let's say, B second. That goes out to a version of our C node, this one, that deals, that has its rotation affected. And then to produce the final transform, this is what I was saying, you can sort of imagine these as compounding. Let's use green, our favorite. I say green, I demand green. So you can imagine this as if it was a compounding of this node. And in here, we're only really dealing with the translation because we need it. And in here, we're dealing with the rotation. The scale might be coming from somewhere else. And for this B node, let's use another color for that. Then it's sort of as if you compound the two stages of that node. So hopefully this makes sense, and this explains what I mean when I say there's a benign cycle and a benign cycle as a coast. The actual process, and I don't know the specifics of Maya internally, but I'd be surprised if they did something too different from it. A classic trick to manage benign cycles is you do keep your nodes as objects or whatever you want to do. They retain their identity, but what you do is you look at values and you do evaluate them twice. So another way to look at these, the last way that we're interested in, will be, let's get some of the transparency off. The last way you want to look at this is that, okay, I have a first evaluation of these two nodes, which are still our 1 and 2, the constraint and the constrained. Then I have a second evaluation of it because there's a cycle, the values change. Now, if after that second evaluation, both the translate and the rotate, because I've done things in this order, remain unchanged, you go, okay, you know what, I'm good. So by comparing the non-changing of a result between these stages, you can get to that point of stability where you can go, okay, this expansion of the graph, which was done by evaluating the node twice, or maybe in the case of the EM/EG, it's done by literally expanding the nodes into copies. You would have to look at the cluster evaluator. I don't know if it's open source or if it's available, but anyway, hopefully you get the idea. Then that cycle is benign. It does mean that you're evaluating those nodes twice. So hopefully that makes sense, and that will make sense of cycles, you know, going further into the various streams. And I'm sure I'll reiterate these, you know, and it'll make eventually even more sense when we will be looking at the actual evaluation graph. But it's definitely easier to understand for the pairing constraint. It is particularly important when you look at these objects. So I would like to bring your attention, and this is why I was saying manipulators are a very artificial thing. And this is, again, not a Maya shortcomings, as much as I like to bash on Maya, you know, everybody's favorite whipping boy, despite the fact we all use it. It's like these are some really hard problems to solve. When you manipulate something, the viewport is a particular loop. It has to take some shortcuts and make some compromises. You might want to see a manipulator in any kind of alignment. So when you go in tool settings, you could be in Word, you could be in Object. So this thing has to have a very weird relationship with the actual transform as the graph uses it, so that you can manipulate something and display it at the same time. And the way that is usually done, you can see how as I perform that action, the manipulator doesn't change. But as soon as I release, that loop is broken. My viewport loop possibly starts again, so the object one gets drawn from the object's transform. If you refresh these very, very quickly, then you might get the manipulator updating as you move something, and that will be very confusing. Now, if you manipulate on a single axis, it's actually pretty easy to keep something coherent. Now, when you manipulate on a plane, because of the orientation of these and because of the way the intuitive, the user intuitive version of this stuff needs to work, there's usually viewport tricks. And if you mess with the graph in the right way, you can usually tell what viewport tricks are being used. So in this case, you can tell about one of them by taking the constraint node. And if instead, so very often, if you want something constrained to a plane, what you will actually do, as you manipulate it freely, it's relatively simple to do things because by controlling all axes in the view space in this case at once, you're also free to do a lot of work. But very often when the user wants to be constrained to something like the plane, if I go slow, you won't see anything particular. What you do is you basically perform a full transform, like if you were working in the view plane, and then you reconstrain it. So you work freely, and then very, very frequently you keep squashing it back to the plane that the user is manipulating. Now, if you go fast enough, that frequency might not be good enough. So try it at home, grab the plane, start messing with it, and you will, the tactile feeling of it, see how it's spazzing out everywhere, you can very easily break some of those tricks. Is this useful? Maybe, maybe not. I mean, this will happen, and it's an artifact of a lot of the tricks that you have to use in viewports. Same with the one where I just pushed it through with the axis constraint. If you pass the point where that fake constraint goes from positive to negative, it will shoot out somewhere into hyperspace. You get the idea, fun tricks. Whereas when you punch values numerically, that is less of a problem because you're also giving the graph a good run. You don't need viewport tricks. So yeah, fun and games, more about cycles. There is plenty cycles. As you write a 3D application, anybody who's written a viewport can tell you it's mixing a viewport and evaluation graph is non-trivial. It's a lot of hard work. And manipulators with all the things that make them intuitive are a lot of hard work. Enough about that. Hopefully you understand what this cycle is that I was talking about. Now, here's the interesting thing I was talking about. So we have to accept that we need to take the translation. Now, I made a mistake in that video where I reconnected the parent the way it is. So, and I also used, because my object was zeroed out on the buffer, I also used the translate coming from the same parent. And I probably can do the same thing here. So let's zero these out. Let's see, where's this parent node? And my mistake there was that with this zeroed out, and I don't know why I was thinking it, probably because I forgot that I had already fixed this cycle, or I wasn't fully thinking of the of all the constraints of this problem, no pun intended. I connected the translate off the parent, and it's it was interesting. So the translate here goes into the target translate, I suspect. Yeah. The target weight is just a manipulation thing. I'll get back to that. I was about to forget. Constraint parent inverse. Then you have the target parent metrics. Like this is all the stuff that comes from our target. That is good. Obviously, that's non-cyclic because this is the dominant element. But the translate needs going away. So what I did, let me make sure, where is that? Let's not make a boo-boo in an explanation video. That'd be pretty embarrassing. So this is what I did. Now, without realizing that while doing that, and now this is stable, obviously, I've practically made this constraint for the most part useless now. And the reason for that is that it is now referencing the parent's translation. So it's always gone like, hey, this is the direction I'm facing. No matter what you do to this, that does nothing. Even worse, you can get it to completely spaz out because these has a translation, and that was by mistake. If that, and you can see if I move this, see how it starts getting a little bit of a rotation, but it's not the kind of rotation I'm expecting. It's not facing down that way. It's going down somewhere like that. It's because I'm considering the wrong transform. So I am going like, okay, the translate corresponding to wherever this is such and such, but I am looking at this one. Worse again, and this is the mistake that you will see in the video, is when you zero these out. So this parent is being framed by its own parent. I'm using its translate, which is now 0. This has become sort of irrelevant at this point. And as I move this parent, you can see that it turns around a lot. And that's because I was simply considering the wrong elements. So I get it to work in the video. And by watching this first, you should understand the mistakes I've made, and it shouldn't be a problem. The long story short about it is that if this is going to be zeroed out to that, and if I want to affect this, what I should have been doing actually, and where is this parent of parent located actually? Let's move that at 0, and let's move this parent, which would have been my case in my rig. Let's move these away, despite the fact that I'm actually constraining this one through its buffer. What I should have been doing is use the word, I suspect, because I don't think I solved it exactly this way in the video, use the parent inverse of these and the translate from that. And then by moving that, I am actually affecting these objects. So in a way, this is pretty cool if you think about it. What is actually happening is that I'm taking two objects to form a system, the parent of this buffer and the buffer itself, which moves around, and I'm driving the rotation of the object that is under the buffer. So this object is now, we should be able to zero this out, and this should give us an even better view of this. We can now have something that translates. The child is free to translate in its own turn without having the rotation affected, and the rotation of this object is going to face something, is going to face the relationship between its parent and a target. Hopefully that makes sense. It will probably make more sense when you see it in the context of the leg itself. But yeah, that's the trick. The mistake I made was that rewiring things, I basically forgot to consider a gap in the hierarchy that I should have considered, or rather suppressed. It occurred to me right the moment I stopped recording, so I wanted to do this. Now, the last thing that you want, this is, I don't think this is really gonna cycle for you. Like it might or might not cluster. I don't think it would. But there's one last cycle in constraints, inside constraints, which is purely an artifact meant to make it easier to manipulate things. So what Maya does is it creates a parameter, and normally this gets renamed to something even more sensible, like the name of the target or something like that. And this being a normal attribute can be renamed. So like an attribute that's created on the fly. What that is so that an animator can select something here. You could even instance it on the constrained object with multiple targets, and you get to control the constraint, the weight of the constraint. So if you have multiple targets, you can weigh them in. You should probably be familiar with these if you use constraints in Maya. The reason for that to exist is largely that offering it the way it is, which is, if you look at the real element that is being driven, it's a float that is inside a compound. So this is a compound of several attributes that is an array. So you have an array of compounds with a float in it, which is going to have very unintelligible names, and arrays are variables. So if people add and take away things, like, it becomes pretty tricky. So again, to address the general case and to let everybody use these, Maya creates a dummy attribute for you to manipulate and to see in the channel box that drives the one that is actually nested deeper into the node itself. You can get rid of it if you want to control the weights otherwise from somewhere else, which in rigging you almost always do, or if you don't need them because you have a single constraint. And that's it. Now this is not cyclic any longer, and it's got everything we need, and it's pretty much good to go. And this is the form that we're gonna use it in the next episode. Last thing, slightly longer intro than I wanted it to be, but around 1 hour 3 minutes in the next video, in the video for the episode proper, I also go over how containers, you might know them as container nodes, you might know them as assets. Those are like their name was changed across Maya versions. The stuff that we're using to encapsulate our components. They can be not really glitchy, but they have peculiarities when you use them in the node editor. So it's very possible that if you downloaded one of the scenes that I offer, you know, every once in a while, I will save the scene as is so that people can catch up to the stream or just play with it if they don't want to rig the actual scene itself. It's very possible that you load one of my scenes up, your view is not set up a certain way, everything appears without connections. So it will be the equivalent, like this has connections, the graph works in the scene, but what happens is that you see something like this. And you play with the scene and everything works, but you don't see the connections. And that's an artifact of how the node editor interacts with the assets. I do spend like 3 or 4 minutes explaining why and how. Towards the very end of the video, 1 hour 3 minutes, I believe. So that is it. I think this is all I have. Sorry if this feels like belaboring a point, but I did not want to redo that episode because it does have an A to B that I liked. But the last third might be very confusing without these things in mind, because I was chasing my tail. I'd rather not do the damage of showing something confusing and closing it by like, oh, now it works and I don't understand why. That's it, and I hope you enjoyed this and enjoy the next episode if you choose to watch it, and have a good day.